Okay, so now we want to talk about what kinds of structures are going to be formed by this lava when it comes up to the surface. So when it was inside the Earth, we talked about things such as batholiths and sills and dikes. Now we want to talk about what happens at the surface of the Earth and what kinds of features are formed. So here's our summary of what we've got so far. Ultramafic material comes from the asthenosphere. It is not very viscous, so it's going to be very runny. It turns into mafic, which is more viscous, and then when it flows on the surface of the Earth, then that's going to be basalt. Intermediate is what's going to happen when you mix mafic and felsic together. It's going to be even more viscous, and it's going to make andesitic lava flows. And then up here, this is what the continents are composed of, so felsic rocks. And it's going to be the most viscous when it's in the form of a lava, and it's going to make rhyolite. So that's our different kinds of magmas, and then the different kinds of lavas that they turn into, and then finally the different kinds of igneous rocks that they turn into. So let's begin by talking about what happens when you've got mafic materials. So mafic materials are not going to be very viscous. It's going to tend to be very runny, and so these kinds of lavas tend to make flood basalts, so that when they come up to the surface, instead of making a volcano, they just run sideways, and that's going to be a flood basalt. And then large, very large flood basalts are referred to as igneous provinces. So LIP, large igneous provinces, is when you have very, very large things that can cover hundreds of square kilometers. Okay, now what kinds of volcanoes can you have? So the cinder volcanoes are going to be composed of cinders. Another name for this is these are scoria cones, and these are going to be the most numerous types of volcanoes. They tend to form around the main volcano, and they produce cinders. Okay, then you've got shield volcanoes, which are going to be the largest. So in this picture here, it shows a comparison of the shield volcano, which is the one on the top. So this would be, an example of this would be the Hawaiian Islands, a shield volcano. The one that's down there in the lower left-hand corner would be a stratovolcano or a composite volcano. And you can see that they're smaller, so an example of that would be Mount St. Helens. Okay, then the smallest one, the one that's on the lower right, that's the cinder cone. And you can see that it is the smallest of the different kinds of volcanoes. The shield volcano is going to be composed of mafic lavas. So this is going to be, again, basalt. So this stuff here, this mafic, tends to make the shield volcanoes. It's going to be very runny, not as runny as what the flood basalt is, but it's still going to be pretty runny, so that when it comes out of the volcano, it tends to go sideways. It doesn't tend to mound up. Then you got your stratovolcanoes or composite volcanoes. These are going to be andesitic and felsic. So these two up here tend to make the stratovolcanoes, whereas these type here tend to make the shield volcanoes. These are going to be the ones that are the most viscous, which means that they stop up the volcano, and then pressure keeps building on the volcano until finally it explodes. So these are the most explosive, eruptive types of volcanoes. So again, the example of this would be Mount St. Helens in Washington State. Okay, we have already talked about what a volcanic dome is. So this is where the ground is being pushed up by the magma that is underneath it. Now what can happen is a volcano can be eroded away, and it can leave behind the more resistant material that was in the neck of the volcano. Okay, so that here is the volcano, and then here's the pipe that went down into the magma chamber. So what can happen is all of this material can be eroded away, and it can leave this thing in the middle, and then that's going to be called a volcanic neck. So an example of this would be Devil's Tower in Wyoming. Okay, then you could also have a volcano that could collapse in on itself. So this is going to be called a caldera. So as long as the magma chamber is full of magma, that helps to support the weight of the volcano. But if for some reason the magma chamber drains, so now this is open air, then it cannot support the weight of the volcano, so the volcano collapses in, and then that's what a caldera is going to be. So you definitely want to review this chart and understand it, because it's going to tie all of this stuff together. So it's going to talk about the plate tectonic features, so the divergent boundaries, convergent boundaries, transform boundaries, and interplate activity. Then it's going to talk and give an example of where on Earth is that kind of activity taking place. Then it's going to talk about what kinds of magmas and what kinds of lavas and what kinds of rocks are going to form as a result of it. And then the very last column is going to talk about what kind of volcano is going to form in these different environments. So make sure that you know that chart for the upcoming exam. Okay, now let's take a break, and when we come back we will talk about volcanic hazards.